Okay, so we have 1.2b in which we're just going to look at some more examples as well as look at this rationalizing the numerator thing down here. So this one's kind of wonky, right? 5 plus x over root x plus 2 root y. So we're going to use that trick we learned at the end of the last video, which is to use the conjugate so that we can cancel out these roots in the denominator. So take a second and say to yourself, well, what's the conjugate of a plus b? It's going to be a minus b. So this is going to be root x minus 2 root y. And then, of course, we're not haphazardly multiplying and scaling our value. We're just using our fancy ones. All right, so what's our denominator going to look like now? It's just going to be x, and then our center terms are going to cancel out, so we would get positive 2 root xy and negative 2 root xy, and so plus and minus the same thing is going to go to 0. So I'm going to have 2 times 2, which is going to give me 4, and then root y times root y is just y. Then we positive times negative, negative. Good. Now up here we have a binomial times a binomial, so we're going to have to multiply that out. I'm not going to do that all the way out for you, but in your final answer you would want to do that. So I'm going to have the quantity 5 plus x times the quantity root x minus 2 root y. And I'd like you to finish that one up on your own. Right here we have one that's really wonky, right? Because I have the square root of 5 over x squared minus 2, and it's the square roots of the whole quantity. So weird. What do I do with that? Well, when I look at this problem, I say, oh, convenient. There's an x squared in the denominator, so maybe I can use that to help me figure something out. So what happens if I make this term and this term have common denominators? So then I can have a monomial of x squared in the denominator and a binomial of something else in the numerator. Well, what's that going to look like? Common denominator of x squared and 1 is just x squared, right? So I'm going to have 5. These are all over x squared now, so I multiply the numerator and the denominator here by an x squared, minus 2x squared, and that's all over x squared. So now we have to think back to our rules and say, hey, I've got a term or a number. This quantity represents a number in the numerator, and I have a term in the denominator. And so I can split it into pieces, right? I can say, okay, well, let's look at them separately. 5 minus 2x squared all over root x squared. Okay, you might be tempted to say that this x squared here can come out, but it can't, because remember, this is all one number, and so you can't square root the pieces. You have to take the whole quantity. So we're going to simplify our last little denominator here and say, okay, well, this must equal root 5 minus 2x squared. And what's the square root of x squared? X. Cool. Rationalize the denominator. All done. Now occasionally we need to rationalize the numerator. Well, that seems weird, but it is useful. Later when we do some calculus, this is something that you might see. We do this when we're taking the limit and we're saying, well, what happens when h gets closer and closer and closer to 0? Well, let's see if we plug 0 in, what happens. But hey, you can't do that because then I'm going to be dividing by 0. Uh-oh. So let's see if we can fix that. And we can do that sometimes by rationalizing the numerator. It's just kind of this fancy little trick. So we're going to do the same thing we did before. We're going to use those conjugates. Anytime I see a binomial, the conjugate's a really useful tool. Okay, so conjugate of A plus B is going to be A root x plus h minus B root x. And then I'm multiplying by that sneaky 1. There we go. Okay. These quantities are going to give us that a squared. These quantities are going to give us the b squared. And then the ab and the ab here are going to create, oops, there we go, ab and ab are going to create a positive and a negative of each other and cancel out. So don't forget that. I'm not just multiplying a by b and ignoring everything else. They are actually canceling out. So this times this is going to give us x plus h. The square root of x plus h times the square root of x plus h is simply x plus h. And then our center term cancels out, so we can just look at the last piece here. Minus root x times root x is x all over h times the quantity, x plus h minus root x. And then x minus x is going to leave us with h over h times the quantity, root x plus h minus root x. And this might seem a little weird to you what I'm doing here, but we're going to cancel those out, and I'm going to be left with 1 over root x plus h minus x. And for a calculus application, this is great because now I can say, well, if h was 0, I would get 1, oh, I made a mistake. Negative and negative makes positive. There we go. Now that makes sense. 1 over, if I plug in let h equal 0, 1 over root x plus 0, which is just root x, plus another root x is going to be 2 root x. Okay, so you can use that for limits and things like that. Don't worry about this part too much. If it confuses you, just focus on that strategy of rationalizing the numerator. Okay. What I'd like you guys to do for a little bit of extra practice, you don't need to do it all, but take a glance here at these simplifying radicals problem. Look and see if they look like something you think you could do. I'm going to focus here for you a little, so hopefully you can see it better. Give those a shot. Don't do all of them. Do 1 or 2. Maybe the ones that are more difficult here at the bottom, like F and G and H, and see if you're able to simplify those out. Then check your answer. See if it worked out to be what you thought it was going to be. Again, come prepared to ask any questions that might have been confusing to you on this video.